another exam 2 probability question. In the Great Fun Amusement Park, there is a small train called Puffing Bertie, which does a circuit of the park. The continuous random variable t, the time in minutes for a circuit to be completed, has a probability density function f with rule that. Sketch the graph on the axis provided. Okay, so first step, whoops, I'm going to plug that into my calculator. F of t dot equals, let's bring in 3 things, and we have 1 on 100 times t minus 10, whoops, and that's when t is between 0 and 20, then 1 on 100, 30 minus t, and that's when we've got 20 to 30, and then 0 else. Done. Now let's draw it. Add a graphs page, f of x, and we're going to have to zoom out so we can see from, so window, let's go from 0 to 40, and let's go from 0 to, I don't know how big it'll be, let's go 50 and see. Okay, 50 is probably a bit too big. Zoom settings, let's change that to 2. Hey, let's change it again. Settings to be half. Alrighty, so sketch it on the graph. So let's just have some 10, 20, 30. So 0, whoops, you'll do a better job when you actually have a ruler. Excuse me. Whoops. I'm going to undo that. Try again. Make it bin. And then flat. And I'm going to tell what this point is. And I'm going to do that by just asking what it's doing at 20. 1/10. Hey, Pippin. Hear that noise she's making? It's because she's about to lay an egg and she wants something to mate with her. All right, next, find the probability that the time taken by Puffing Bertie to complete a full circuit is less than 25 minutes. Okay, so we're trying to find probability of that little section in there. So on CAS, I'm going to go from, we can do from 0 or you can go from 10. It doesn't really matter because we've already defined our graph, but as long as we're going up to 25, you can put negative infinity if you want to. F of t dt, give the exact value. So let's just do that again and not do, no, it's still exact. It's worth 2 marks, so I'm going to put this in as well. So if I make a mistake somewhere along the line, at least I might get marks for that. 7 on 8. There we go. Find the probability that x is less than or equal to 5 given that it's less than or equal to 25. So that's given that, remember, it's less than or equal to 15 and less than or equal to 25, which is just less than or equal to 15 over probability less than or equal to 25. We know what that one is. We can find this one by just modifying over here Let's just change that to 15. 1 on 8. So we've got 1 on 8 divided by 7 on 8, which is 1 on 8 times 8 on 7, which is 1 on 7. There we go. Just checking the answer's correct. It is. Whoa, man, so fast scrolling. Whee. Okay, the train must complete 6 circuits between 9 and noon. The management prefers Puff and Bertie to complete a circuit in less than 25 minutes. Find the probability, correct to 4 decimal places, that of the 6 circuits completed, at least 4 of them take a certain amount of time. So this is when it switches. So now we've got 6 circuits. So we've got a number of trials, n equals 6. And we want them to be less than 25 minutes. So we want to know how many of those 6 trials are less than 25 minutes. So we're going to say, let x be number of circuits less than 25 minutes. So x is binomially distributed with 6 trials, and the probability that it will take less than 25 minutes is 7 on 8. And we are trying to find that out of the 6, at least 4 of them. So probability that x is greater than or equal to 4. That's what we're trying to find. So I'm going to use my binomial CDF on my CAS. Probability, distributions, binomial CDF. Number of trials is 6. Probability of success is 7 on 8. That's totally fine for you to put little fractions in there. The lower bound is 4 and the upper bound is 6. Okay, there we go. And find the probability corrected to 4 decimal places. So 0.9709. There we go.